Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Kalina from Business Review, and I will be your host today. It is our pleasure to have Donaldson with us today, who will be presenting this webinar titled Filtration Solutions for Fermentation of Plant-Based Protein. Today's guest speakers are Scott Grimes, Technical Specialist North America at Donaldson, and Dominic Michel, Technical Specialist Europe at Donaldson. I would like to welcome you to our webinar platform on 24. You will notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask any questions, you can send them in via the questions widget. Just type them into the box at the top right corner of your screen and click submit. Towards the end of this session, we will allocate some time to address any thoughts and questions that you may have. Please use the yellow help widget if you require any assistance, and you can also move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome Scott Grimes. Scott, over to you.
Thank you, Kalina. Good morning and good afternoon. On behalf of Donaldson North America's Process Filtration team, I welcome you to this webinar. I hope that you are all safe and enjoying the spring weather with family and friends. Before going too much further, I wanted to give you a high-level overview on Donaldson Company. Much like other 100-plus-year-old industrial companies, Donaldson's roots were formed in the agricultural market segment. In fact, inventing the very first air intake filter for a farm tractor. Since this time, Donaldson has grown exponentially into a $3 billion per year company. As an employee of Donaldson, what I really like is our investment into people, research and development, and our local community spread out across the globe. Since 2014, Donaldson has made 6 strategic acquisitions, one of which you'll learn about in this presentation. Filters. It's all about filters, helping to protect process integrity, operations, and people. For the past 100-plus years, Donaldson has manufactured filter solutions for almost every imaginable market. Today, our focus is on a growing market segment, plant-based proteins for the food and beverage industry. Donaldson Process Filtration value proposition is detailed in the following manner. Dedicated application engineers designing filtration solutions to help you meet your unique requirements. Examples of this support would be lab testing, clear understanding of regulatory and safety standards. In-stock inventory selection, kind of a hot button these days. But we support this with product design and certification to sanitary and hygienic guidelines. We have a broad range of solutions from filter housings to high-performance filter elements and even complete engineered solutions. And lastly, we make it easy for you to find and purchase what you need with our e-commerce platform or our online chat feature, and of course, dedicated salespeople in person. Obviously, we've all read about the growing demand and variety of plant-based protein products coming to our grocery store shelves. And I'm going to assume that most of you are aware of the fermentation processes involved in producing plant-based proteins. However, in the slides to come, I'm going to give you a brief introduction to some exciting news here at Donaldson. Of course, there are contamination risks in food processing, but following current best practices, processors can gain protection against contamination, allowing for the optimization of your process. My colleague Dominic and I will show you how proper filtration techniques, backed up by standards for air, gases, and liquids used in advanced food ingredient fermentation can help you achieve best possible outcomes. But before I proceed any further, let's have our first poll question. Over to you, Kalina.
Thank you so much, Scott. Yes, indeed, this is our first poll question for today's session, and it is, do you already have running fermentation processes in your plant-based food production, or are you looking to grow into that market? The possible answers are, we already have a process in place, we are looking to install a plant-based food process, or we don't do fermentation ourselves. Please select the answer that is relevant to you and click submit. Let's just give the audience members a couple of seconds to vote on this poll. Okay, so 17% of the audience members have voted for we already have a process in place. Then 19% are looking to install a plant-based food process, and 63.4% do not do fermentation themselves. Over to you, Scott.
Thank you, Kalina. That's some very interesting statistics. Thank you for taking the time to respond to our poll. So today's subject, filtration solutions for fermentation of plant-based proteins, requires me to make an introduction to a recent acquisition made by the Donaldson company. Donaldson acquired Solaris Biotech recently in December of last year. Before my colleague and I walk through Donaldson's filtration solutions, I would like to give you a brief overview of Solaris Biotech. Solaris Biotechnology is an Italian company specializing in fermenters and bioreactors for research and development and production purposes. Though initially more industrially focused, today Solaris divides its activity into two branches. First, we have Solaris Lab, dedicated to laboratory scale equipment from 120 milliliters up to 20 liters. And Solaris Industrial, which is committed to totally customizable GMP pilot to industrial equipment up to 30,000 liters, and ultimately to assist in the design and manufacturing of full turnkey solutions. So let's talk about this growing demand. The variety of plant-based protein products and the sales of plant-based foods that directly replace animal products has grown 12% to 1.3 billion in the 52 weeks ending July 31, 2021, and 53% over the last 2 years. Sales of meat alternatives has jumped 11% during this time to roughly $900 million. This is a very exciting time to be in this industry. So let's take a look at the process itself. Bioprocessing is a method that uses living organisms or enzymes to produce a desired target product. One process that I personally am very excited about is industrial biotechnology, which can be the biotransformation of plant-based proteins into finished food ingredients. Closely tied to this is agricultural biotechnology, which is the improvement of crops that offer better nutritional values or better resistance to pests and climate change. In the area of conservation, we have environmental biotechnology. These are target products that can help remove pollutants, such as in wastewater treatment. And lastly, we have medical biotechnology, which includes vaccines, biotherapeutics, hormones, and antibodies. My colleagues at Solaris are ready to assist you in your next project. Next, I'm going to briefly review some of the common challenges in fermentation. or more importantly, how to mitigate risk by looking at your critical control points, such as temperature controls, or having clearly defined flow conditions into the reactor. These, along with other parameters such as pH, dissolved oxygen content, turbidity, optimal mixing with low uniform shear mixers, and adequate transfer of gases must be closely monitored. Rest assured, Solaris's sensor and control platforms provides a very intuitive and fully scalable method for maintaining these critical parameters. To summarize, the design and construction of bioreactors must be kept sterile from the starting point through to the end process. Solaris solution models start at the R&D level and work all the way through industrialization of your process, helping to achieve the best possible outcomes. And lastly, Solaris can offer tangential flow filtration for post-fermentation processing of end products. Solaris has completely customizable pilot and industrial scale tangential flow filtration systems based on either microfiltration or ultrafiltration. We can also offer a benchtop automatic tangential flow filtration system designed following the most up-to-date criteria for GMPs. Typically, these units handle up to about a half a meter squared of total filtration area and is equipped with multiple modules, which make it ideal for innovation, as well as automatic process sequences. And I'd like to point out that there is an optional CFR Part 11 available. And lastly, Solaris will offer a multitude of different membranes: spiral rounds, ceramic for those aggressive or critical conditions, hollow fiber, such as for harvesting of protein or biological samples. We find these easy to scale up. And lastly, cassette style, mainly used in biopharmaceutical applications. Please be on the lookout for a more detailed webinar on all of the products and services offered by Solaris Biotech. Now I'm going to pass the presentation off to my colleague, Dominic. Hi, Dominic.
Hello, Scott, and also welcome everybody else from my side. So I hope you're all safe and well, and I'm very glad you made it to our webinar today. So as Scott was already saying, today we are looking at filtration solutions to help you protect your fermentation processes. And as you all know, the fermentation process is one of the key process steps during the production of plant-based proteins, and therefore it is really critical for a high-quality final product. But on the other hand, it's also one of those processes that needs a lot of utilities, has a lot of exchanges with the environment. So for example, if you think of gas in, a lot of bioprocesses have a mandatory need for aerobic aeration with oxygen. But also gas out is a very important topic because you do want to prevent the dissipation of potential pathogens into the environment. So aseptic condition, all in one, are very critical for bioprocessing. And another good example we have is nutrient water that is needed to even start the process sometimes. So all in all, it's a very sensitive process while still using a lot of different sources of media or ingredients. And therefore, it really needs to be well protected from all sorts of influences and contaminations. And that's why we need filtration solutions that will both help you protect your product, but also protect your process, that it still will work as intended. And with these filtration solutions, we are also addressing one of the main challenges during fermentation steps we are trying to show here on that slide. Because all living microorganisms, even down to their simplest form, are competing for available resources. And if contaminating bacteria enter your process, they are stealing nutrition from the fermentation bacteria. And they are also adding variables to a very sensitive process that usually needs to be standardized as much as possible. And additionally, contaminations can even lead to the production of toxic or inconvenient metabolites. So it's not just the bacteriophages we see here that are the problem. There are also fungi, molds, yeasts, other bacteria that are competitors for resources and can lead to the problems we just mentioned. So let's talk about how can we achieve this microbiological safety we need within the bioreaction process. Because with our Donaldson LifeTech portfolio, we fully concentrate on this part of process filtration. So the products are designed to help you protect your liquids, your gases, and your steam that is being used in your process from all sorts of contaminations that might happen during or before the production. So let's look at these utilities a little closer. Let's start with water. Because depending on where you get your water for your process, contaminations can enter the water from different sources. For example, the well, from the piping, from non-sterile tanks. They can already be part of your water when they come from the well, or they enter the water from the environment during the whole process. So there we need to achieve a very high water quality, which also applies to the quality standards for water for injection. Next up, we have air and gases, which also need to apply to certain standards. For example, compressed air for food contact needs to apply to the ISO 85731 and achieve certain quality classes in particle content, oil content, humidity, but also needs to be free of microbiological contaminations. And lastly, all the steam used for sterilization processes needs to be classified as clean steam. So here also filtration plays a very big role. And we do have a very fitting application example here demonstrating how Donaldson can support protecting your fermentation process. This customer here had a bio-yeast production from purely natural ingredients and relied on a complete sterile processing from the first drop of yeast, the inculation, through the whole fermentation process. So Donaldson was here involved as early as in the project planning phase, and we did provide, of course, the correct products, but it did not stop there. We also provided the expertise for the optimal filter installations, the optimal inline sterilization best practices, and also for all the other filter handling. And now before Scott will go a little bit more into detail of the different utility requirements and what filtration solutions Donaldson can offer here, we do have our second poll question here. So Kalina, you can go ahead.
Thank you so much, Dominic. The second question is, where do you think lies the greatest risk for your food ingredient bioprocess? In the contamination from nutrient or processed water, in the contamination from the environment, contamination from air or gases, contamination from steam, or all of the above? Again, let's just give the audience a few seconds to vote on this poll. Okay, so 2.6% have voted for contamination from nutrient or processed water. 5.3% have voted for contamination from the environment. Then another 2 from the third option, contamination from air or gases, and the majority of the audience have voted for all of the above. Thank you very much, everyone, for voting, and I'm going to pass on to Scott.
Thank you, Kalina. And again, thank you, everyone, for your input. We find it very valuable. So let's first talk about processed air or compressed air and processed gases. I can't stress enough that it's important for you to get to know your compressed air. And it starts with familiarizing yourself with the ISO standards surrounding compressed air that Dominic has previously mentioned. And if you're not familiar with these standards, please feel free to contact myself or Dominic after this presentation. You must always remember that contamination comes in different forms. Particles including microorganisms, condensate or humidity. And even if you're using an oil-free compressor, you still must concern yourself with hydrocarbons that enter your system through the atmosphere. All of these conditions must be carefully looked at prior to your system's point of use. Regardless of the compressor design, I want to stress that proper upstream filtration and dew point suppression, and of course hydrocarbon removal, will serve as the foundational elements for producing sterile compressed air. And technical gases are no different. Whether you're generating them on site or using bottles, you must utilize available filtration technologies to guard against any potential contamination. Fermenters, whether they're aerobic or anaerobic, operate in this, and I'm going to use some industry terms here, gas in and gas out. So your supply gas into the fermenter could be a bubbling reactor, but then those gases need to be exhausted off. And so that's kind of your flow principle there. I just talked about the importance of filtration for compressed air and gases. So here we're going to review the needs for gas out, or the vent filter. Gas filters operate in much the same manners as gas in filters when you actually look at the filter media. The sole goal of these gas out filters is preventing contamination. But this is in the area of preventing harm to operators or providing environmental safety. So as you see here, aseptic conditions are needed in all areas of bioprocessing. In addition to these challenging conditions, vent filters must also be compatible with all process conditions, including CIP and SIP sequences. Chemicals and temperatures also need to be reviewed before you commission your vent filter. Steam quality, I noticed none of you found any challenges with that, and I'm not surprised. But I'm going to take a couple seconds here just to point out some important talking points. My point of view on steam quality and the role that Donaldson plays is focused primarily on equipment protection, such as heat transfer, where you might be using industrial steam or culinary steam to generate clean steam through a heat exchanger. The application for clean steam is typically for the sterilization of product contact surfaces and also your filter elements. It's important for you to know your regional pharmacopoeia requirements. Regardless of where you are on this earth, we find a lot of similarities. All will have guidelines that help you with pH, TOC levels, CFU counts, endotoxins, conductivity, non-condensable gases, and moisture. Again, Donaldson's role in the area of steam conditioning is to help protect equipment typically used in heat transfer applications. The demands for clean water, however, are universal, and it's paramount in bioprocessing. For an example, upstream processing of water-soluble glucose, which will help provide the environment necessary for cell growth. This food, carried in by the water, and the gases, whether it's oxygen for aerobic, or CO2 or nitrogen for anaerobic, along with temperature control, help support the 4 distinct growth stages in fermentation. The role that Donaldson assumes in this is the reduction of suspended solids found in your facility's incoming water supply, and the initial bacterial reduction. And lastly, the final guard or security filter at that point of use, utilizing our sterile grade filter membrane. Like steam, please check with your regional pharmacopoeias for best practice of purified water or water for injection. Now I'm passing back to Dominic for a quick overview on filtration retentions and a synoptic application overview.
Thank you, Scott. So, to support you in protecting your product from incoming contaminations, and especially from bacteria that could influence your protein production, is our main goal. So, our filters need to be able to support in building a barrier for contaminations, so your process stays safe. So let's look a little bit into the requirements for such a filter for food processing, able to achieve this kind of contamination control. So here on this slide, you can see an overview over the size ranges of typical contaminations we could have. And on top of that, you can see a sizing scale in micrometer, and you can see many particulate contaminations like sand, dust, or spray. But as we learned until now, microbiological safety really means concentrating on retaining harmful bacteria from your process. And on the chart, you can see bacteria size ranges start at around 0.2 micron up to around 30 micron. So this is exactly the range where microfiltration needs to focus on, because what we need now are filters capable of retaining all of these contamination sizes, and hence this 0.2 micron rating as the smallest bacteria is a very critical parameter for sterile filters. How are sterile filters for the food and beverage industry now validated? Sterile filters are validated by using a very special microorganism as a measurement standard, and this one is called Brevondimunas diminuta. This microorganism has a very typical size range of 0.2 to 0.3 micron, so it's the perfect size to validate sterile filters. And per official definition, a sterile filter is defined as a filter holding back every single Brevondimunas diminuta except for 1 out of 10 million organisms, which are challenging 1 square centimeter of filter surface. So let's break that down. You can calculate a retention rate out of this, which calculates to 99.99999% of all bacteria need to be retained by this filter. And in filter language, there's the so-called logarithmic reduction value, which can be calculated out of this retention rates of 99.99999%. And if you calculate this to an LRV value, you get an LRV of 7. So as a summarization, only filters achieving an LRV of 7 for Brevondimunas diminuta are actually capable of filtering to a sterile level. So let's bring that all together, what we learned so far, and look at this example. So here we can see a typical fermenter for a plant-based protein production process. And I'm pretty sure a lot of you will know how these look. This example here was provided from our colleagues at Solaris and resembles one of their recent projects. And as you can see, there are many inlet utilities, but also outlet utilities that are connected to this process. Let's start on the top left, where we have the gas in, as there are 2 inlets, one for air and one for oxygen, both being filtered with a redundant sterile filtration installation. So 2 filters actually in series. And on the upper right, you can see the gas out. So there we have our sterile venting filter, which makes sure that also the gas outlet of our fermenter is under control. On the right, we have the clean steam inlets. So these are providing pre-filtered, pre-treated clean steam for the sterilizations, the steam bridges, and other applications. And then on the left, we have chilled water inlets, which are also providing pre-filtered particle-free water for several applications. And there are even some applications that can't be seen on this diagram, like we talked about nutrient water, where we need maybe a sterile water filtration, or cleaning water treatment, where we also need a particle-free water to reach a certain cleaning standard. So as you can see, there are many applications we can cover with our filter portfolio. And now Scott will take us through the Donaldson products that fit these applications.
Thank you, Dominic. With Donaldson's evolving process filtration portfolio, we have designed a product category specific to the demands found in fermentation and bioprocessing. These are LifeTech filtration solutions for process utilities such as water, air, and steam. Specifically designing products that provide strength and achieving improved pressure stability, optimizing performance such as excellent flow rates and lower pressure drops, and lastly, availability, using our single-piece flow manufacturing techniques to help provide filtration solutions in a timely manner. One specific area of mass improvement is our ISO Class 7 clean room used in the manufacturing of our high-valued LifeTech depth and membrane filtration solutions. In the theme of a picture is worth 1,000 words, here you see one of our filter media pleaters, in case you're wondering what you're looking at, in actual operation in our ISO 7 class, or Class 7 clean room, sorry. Now let's take a look at some of the product we've been referencing. But before I do, please take note of the unique polypropylene cage design of the filter element on the right side of your screen. The structure you see here is called a Rome structure. It helps provide improvements in mechanical strength and flow distribution. The actual product featured here is the LifeTech polyether sulfone filter element. It is a sterile grade pleated high performance membrane for liquid filtration. It is extremely water loving or hydrophilic. The outstanding performance of this filter element is based on its state-of-the-art filter media. The membrane distinguishes itself by having an asymmetrically designed pore structure. The pore size steadily decreased towards the center of the medium, resulting in high pore structure, ultimately providing sterile grade filter performance with a log reduction value at a minimum of 7 at 0.2 microns. And of course, we have other micron selections available. All of our sterile LifeTech filter modules manufactured by Donaldson are integrity tested to verify compliance with established quality and design specifications and to ensure consistent and reliable performance. Thinking back to the application of gas in and gas out, here we have two excellent solutions that will help provide you with the contamination solutions or mitigations needed for sterile air and gases. The white cage structure element that is pictured here is our LifeTech PTN sterile membrane filter, utilizing Donaldson's Tetra Tech's hydrophobic or water-hating PTFE membrane for exceptional flow characteristics in all critical processes. And on the far right, you see our PSRF-X, X for extreme, in case you're wondering. It is a pleated sterile membrane utilizing our Tetra Tech membrane, but it is co-pleated to a borosilicate matrix, all supported by stainless steel hardware, providing high filtration efficiency in demanding process applications, including high temperatures that you might find during SIP sequences. These temperature values in excess of 200 degrees centigrade, which is close to 400 degrees Fahrenheit. Both of these hydrophobic membrane filters present a log reduction value at a minimum of 7 at that critical 0.2 micron level. And lastly, our steam filtration solution is supported with our LifeTech PGSLN. It is a regenerable pleated stainless steel filter element that captures contaminants such as particles that are abrasive to valves and seals. With close to up to 2 square feet of media per 10-inch element and available in 6 different micron values, we feel that when it comes to steam filtration, we have an excellent solution. The PGSLN can be used in higher capacity, lower pressure applications, or when your footprint or providing when you have reduced space, but you still need to get a filter element in operation. This solution usually fits the need. Before I pass the presentation off, I do want to mention that Donaldson offers a full line of filter housings, ranging from industrial to fully sanitary housings, including all applicable standards. Now for our third and final poll question.
Thank you so much, Scott. The third question is, what is your company's approach to sterile membrane validation and integrity testing? Please select between in-house filter management and integrity testing, in-house filter management and external integrity testing, external filter management and external integrity testing, or we don't do integrity testing of our sterile filters. Okay, so we have an even choice between in-house filter management and integrity testing, and we don't do integrity testing of our sterile filters. 40% for both, and another 18% of the audience members have voted for external filter management and external integrity testing. Again, thank you everyone for your participation, and now I will hand over to Dominic.
Thank you. So, yeah, I really want to follow up this question here now with mentioning all the additional services Donaldson can provide in optimizing your process. For example, Donaldson offers a complete lab service portfolio, including used filter analyzers, so we can maybe double check your filter choices, we can analyze for troubleshooting, but we can also do media analysis. For example, a water analysis for particles or filterability testing. So we don't just choose the right products, but they will also have a long lifetime in your application. And lastly, integrity testing, both for hydrophilic and hydrophobic filters, is just so critical, and we offer these services both at your place or external in our production. And we want to close this out now, that we really hope that you learned today that Donaldson is here to help. We have a large application support department, including specialists who support you in choosing the right products, optimizing your filter handling, but also can support during new installations with the proper sizing, assisting with setting up SIP or CIP routines, and many more. So at the end, I really hope that you will all stay connected through our social media channels like YouTube or LinkedIn. And we also want to mention our Donaldson shop here, where without registration, just with a guest account, you will be able to quickly find the filters you maybe need, but also the support you need. So thanks everybody again from our side for your participation in our webinar today. And now I think we can go to the Q&A section.
Yes, indeed. Thank you, Dominic. Just a reminder for the audience members to send in questions at the top right corner of your screen where the Q&A inbox is. Even if we don't manage to answer your question today, all of your questions will be made available to the presenters to be answered at a later date. So to start with the first question for today, it is what is the scalability of your Solaris bioreactors?
Yeah, I can answer that one, and thank you for this question. That's something that we're very excited with Solaris because it is a solution model that starts at the R&D level or the lab scale and then can transition into piloting when you're trying to qualify the product all the way through commercialization to industrialization. So you might remember that I mentioned about, from roughly a 0.5 liter size benchtop reactor to a 30,000 liter reactor or even larger. So I guess the answer to the question is that the portfolio is extremely scalable. Thank you.
Thank you so much, Scott. The next question is, will Donaldson be at any exhibitions this year?
Yeah, maybe Scott, I can take this.
Perfect,
because
yep.
We recently put together a really long list of exhibitions we going to visit this year. And yeah, we have this right here. So there are a few examples that may interest you. Like we're going to be at the Plant-Based World Conference in New York, for example. Solaris is going to be on the Future Food Tech Alternative Proteins Summit, also in New York, and also be there as a partner. And we at Donaldson, we are really looking forward to the Drink Tech this year. It's really going to happen again in person in Munich, in Germany. So that's one big one for us. And I'm really looking forward to meet some of you there and really get together again in person and discuss some things. And we also have some new things to show. So yeah, thanks. We are going to be on a lot of exhibitions this year.
Thank you so much. The next one is, do you offer guidance in filter sterilization?
Yes, we do. So I did just mention it in the additional services we can provide as Donaldson. So filter sterilization is very critical. So this needs to be really in check with what the product can handle. And so it's in terms of steam temperature, but also steam quality. So all of these needs to be in line that the real sterilization cycles and integrity tests and everything is really, achieving these levels the customers are expecting. So yeah, we can support with that. Just contact us and we can look at the process at your side and help optimizing it for a longer filter lifetime.
Thank you so much.
Thanks.
The next question that we have is, do I always need sterile water?
No, you don't. So you don't always need sterile water because, as we mentioned, for example, for cleaning water, particle-free water is totally fine. But as soon as you get to the points of processed water, ingredient water, or nutrition water, we would definitely recommend a sterile filtration. But it's not always needed. So again, let's look together at the applications you have here, and then we can help you choose the right products, the right filtration steps, and so on.
Thank you very much. Another question that came through is, how long is the life cycle of the membrane or filter? Do you have solutions for phage contamination?
I I can help address that. And Dominic, if you have anything you want to add after I'm finished, please feel free to do so. With proper, for sterile gas filters in your gas in application, with proper pre-filtration, the filter element life cycle should not be determined by particle loading or high differential. It should actually be determined by how many SIP sequences it's been through. Now, in theory, filter elements with plastic cage design can last over 100 cycles, but that's hard to obtain sometimes in the field, mainly because of the challenges of steam quality and steam temperature. And yes, when it comes to phage, we do have data showing the retention of some phage, and this would be through our SRFX filter element. And so if you want more detailed overview of this, please make sure you submit your follow-up contact information so that we can address this in a more detailed fashion. Thank you.
I'd just like to add to that question maybe that we really need to differ also between sterile water filters or sterile air and gas filters, like Scott mentioned just. So like he said, sterile air and gas filters will not block. They will just, the measurement of the lifetime will be in sterilization cycles and then integrity testing if it is still okay or not. And for liquid filters, it will be more of a combination of is the filter still sterile, but also is it blocked to a degree where I can still use it? And that's where then regeneration procedures get into the play. So we can also adjust, help you adjust these. Thanks.
Thank you.
Thank you both so much. Another question we have is how and how often should the filters be cleaned?
That goes kind of hand in hand. Yeah, sorry.
Yeah.
Scott, you can go
No,
ahead.
it kind of fits. So your CIP and SIP sequences will be dictated by your GMPs in your process. And during that CIP and SIP, if you're doing it between batches or, based on how many hours of operation. And so when you say cleaning, for instance, like our steam filter, which is a regenerable filter element, it needs to be cleaned based on differential pressures. And typically the cleaning protocol for that is using ultrasonic bath. But with our hydrophilic and hydrophobic membranes, the cleaning of them is more of a sterilization than it is cleaning. And that will be dictated by your GMPs. I hope that answers the question. Dominic, you want to add anything to that?
No, that was pretty much, complete. That's, nothing to add here.
Okay.
Thank you.
Thank you for the question.
Thank you so much. Thank you again. Another question is, what do you mean by regenerable stainless steel? It was on one of the filters.
Yeah, I kind of touched on that. So our PGSLN, you can regenerate because stainless steel is very rugged and very durable. And this particular element can withstand pressure drops in excess of like 3 to 4 bar pressure differential. And the regeneration process in the world of good, better, and best, best would be an ultrasonic bath, but if you don't have access to that, then you can use alternative means, such as clean out of place in a caustic or an acidic bath. But please don't use a high pressure powered water gun on it because that can be very destructive. Thank you for the question.
Thank you as well. The next question is monitoring air quality by an internal lab in the plant could be a solution in place of doing an integrity test on the air filters?
That really depends on the kind of monitoring we are doing. So are we really monitoring for a live bacteria count, or because If we don't, then I don't think there is a way around sterile filtration and integrity testing this sterile filtration. So that really depends on the kind of quality tests that are being done, and comes also again down to a really risk analysis. So is this being done all the time, or is it just being done like once a week, and then your risk is going up of you having a broken filter in your process? So a lot of things playing into the whole topic. So yeah, we need to look at this in more detail, I think. Scott, anything to add?
Yeah, I would suggest that if you're going to do online monitoring of compressed air and gas quality, and if you're looking for micro counts, and if you're not getting any hits on those micro counts, then perhaps it is potential to push out your SIP sequence. But there's a case of diminishing returns all the time with this kind of trend analysis or risk analysis. So again, as Dominic said, please reach out to us on a one-on-one level. Make sure we have your contact information and we can review this in more detail. But great question. Thank you very much.
Thank you very much. And the last question that we'll have time for today is, how do you describe the difference between tangential filter, like micro ultrafiltration or RO, to a sterile filter? Is it only by LRV value?
Scott, you want to go on that?
So how do I describe the difference? So first of all, tangential flow is cross flow. And the filter elements that I highlighted towards the end of the presentation are known as full flow or dead end filtration. The performance of cross-flow systems will be up against certain quality standards because you have a permeate and a filtrate. And you might be looking for viable cell count or protein levels. Whereas on a dead-end filter, we are looking at one object and one object only, and that's the integrity of the filter media against this ASTM HIMA challenge test for GrevDem. So the difference is that even though you can get particle separation on a TFF level that is below 0.2 microns, the sterile membrane is there to provide a validation against a reference standard for sterile, where you might not find that in tangential flow. I think that's the best I can do to describe that off the cuff. Again, if you're looking for a more detailed explanation, I might need a little research time to formulate a proper response, but I certainly appreciate the opportunity to address this question. Thank you very much.
Thank you everyone for your many questions, and thank you Scott and Dominic for answering those. Again, a reminder to the attendees that your questions will be available to be answered on demand, and also you can still send them in even right now. But that just leaves me to thank Scott Grimes and Dominic Nihel for this presentation, and to thank Donaldson for sponsoring this session. To the attendees, you will receive an email tomorrow telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.pmi-live.com. We look forward to sharing further webinars with you, so please do keep an eye on the website just mentioned, and you can also follow us on Twitter at BR Webinars, and join our LinkedIn group, Business Review Webinars PMI, for daily updates. Thank you very much once again, and I hope that you all have a great day.
Thank you, everyone.
Thank you. Bye-bye.